What's up guys, it's Timon Fias, and today's video is on AQA level chemistry, physics and math tutor, Amines question paper. So, question 1 is multiple choice question and it says methylamine reacts with bromoethane by nucleophilic substitution to produce a mixture of products which is not a possible product of this reaction. Okay. So, methylamine reacts with bromoethane by nucleophilic substitution to produce a mixture of products which is not a possible product of this reaction. So first things first, I can see I've got two ions, positively charged and negatively charged part, C2H5NH, C2H5NH, whereas in C, you can see here we've got two methyl groups, CH3, 2. That's not a possible product, therefore. So you need to look really precise at everything in the formulas they give you. At 2a, this question is about amines. Given an equation for the preparation of this by the reaction of hexane with excess of ammonia. Okay, so what does it say? Preparation of this by the reaction of 1,6-dibromohexane with an excess of ammonia. So dibromohexane. So it's going to be actually, let's do skeletal formula. I think that would make more sense. So methane, ethane, propane, butane, pentane, hexane. 1, 2, 3, 4, 5, 6, 7. I've got a bromo here, 6 carbon, and I've got bromo here on the first carbon. So I just put it as that. And I'm reacting it with ammonia, excess of ammonia, so I know it's going to be more than one ammonia. But what I'm going to form is a diamide. So what it's going to be is something like this. I've got my NH2 here, and here I've also got NH2. I also formed this salt H4Br, and then to balance it, there should be a 4 here and a 2 there. 2 there because I need the 2 bromos, and then a 4 here because I need 4 nitrogen. That's 1, that's 2, that's 3 fourths. I need a 4 there. And that's how you do that. Part B says complete the mechanism for the reaction of ammonia with 6-bromohexylamine to form that. So it is actually very simple. Lone pair of electrons NH3, attacks partial positive carbon, CBr bond breaks. And that it. And then it says, oh, but this is obviously, yeah. So what I need now is, still got my NH2, still the same structure, but instead of this bromo, I replaced it with this NH3. NH3. And the NH3, the nitrogen is positively charged. And then what happens is the NH3 acts as a base, takes a proton, leaves, and then you just form your NH2 nitrogen lone pair of electron ion plus your NH4 plus ion. That's where the second mark came from. So this first mark, it's just the idea of, you need to be able to practice these kind of mechanisms with skeletal formulas as well, because it can always give you this kind of thing, and if you don't know where the curly arrow is going, I'm going to be able to get the marks. And that's that. The cyclic secondary amine suggests the structure as a byproduct. Well, it's going to be something like this. 1, 2, 3, 4, 5, 6, NH. 1, 6 di aminohexane can be formed in a two-stage synthesis starting from a butane, dibromobutane, 1,4-dibromobutane, suggests the region and condition for each stage in its alternative synthesis. So in a two-step synthesis, so the first thing I need, diaminohexane. Oh, so I need to go from halogen alkane to nitrile, and then I reduce the nitrile to my to the amine. So stage 1, I'm going to be using KCN, condition aqueous alcohol, Stage 2, region and condition hydrogen, condition and nickel. Remember, this is obviously catalytic hydrogenation. You could also say lithium aluminum hydride in dry ether, etc. etc. Explain why 3-diamino protein pentane is a stronger base than ammonia. Classic question. You just need to be very specific and apply it to the question. So in 3-3-amino pentane, the lone pair on nitrogen is more available. Because of what? Because of the alkyl groups. Alkyl electron pushing / the inductive effect. That's it, really. 2 mark. Justify the statement that there are no chiral centers in 3-amino pentane. So justify the statement. For 1 mark. Well, the justify the statement that there are no chiral centers in 3-amino pentane. Well, no carbon atoms attached to 4 different groups. No carbon atom is attached to 4 different carbon atom is attached to 4 different groups. Question 3. Methylamine reacts with bromoethane by substitution to produce mixture products, which compound is not a possible product of the reaction. So all I would do is really look at the list. NHCH, CH3, and CH3, and CH3, and CH3, 2. Why would I have 2 CH3s in this case? 2 methyl groups. Therefore, the answer is D. That is not a possible product for this reaction. Question 4. The infrared spectra A, B, and C are those of a primary amine, a tertiary amine, and nitrile, but not necessarily in that order. Give the letter of each compound in the correct box. For 1 mark, well, yeah, you're just going to be using your periodic infrared spectra data. So, for primary amine, is going to be C. Tertiary amine is going to be B. And nitrile is going to be A. There are 3 secondary amines that contain 4 carbon atoms per molecule. 3 secondary amines that contain 4 carbon atoms per molecule. Draw the skeletal formulas of these 3 secondary amines. Skeletal formulas. So I can just have this secondary amines, or I can have that, or I can have that. Primary amines can be prepared by the reaction of halogen alkanes with ammonia or by the reduction of nitriles. Yes, justify the statement that it's better to prepare primary amines from nitriles rather from halogen alkanes. With halogenoalkanes, let's see how many marks it is first. That's going to play a big part. It's 2 marks. Okay, with halogenoalkanes, it is a further reaction. Whereas with nitriles, no further reaction, and impure product and mixture of products formed with halogenoalkanes. Guess you can say that. Part D draws structure of primary amine with 4 carbon atoms that cannot be formed from a nitrile. Cannot be formed from a nitrile. Or we could say single product high atom economy. So it looks something like this, really. With 4 carbon atoms that cannot be formed from a nitrile. Yeah. Part E says, given an equation for the reaction that occurs, a student dissolves a few drops of propylamine in this much of water. So propylamine, so methyl, ethyl, propyl, so CH3, CH2, CH2. So that's pretty nice. CH3, CH2, CH2, NH2 plus H2O. Reversible reaction, and what you're going to form is you're just going to form CH3, CH2, CH2, NH3 plus OH minus. Describe what is observed when universal indicator is added. Green turns blue. Part F, given the equation for reduction of nitrobenzene to form phenylamine. So all that's going to be is nitrobenzene C6H5NO2 plus 6 from the hydrogen from reducing agent to form, well, you're going to form C6H5 obviously, because phenylalanine NH2, phenylamine NH2, and then plus with 2 H2Os. Why do I add 2 H2Os? Because if I count the number of hydrogens on the left hand side, that is 6 plus 5, 11. So I also need, I need 11 on the right hand side as well. But you could also show it as this. And sometimes in the exam, if you only know this way, that's perfectly fine. So this with the NO2 here, plus your 6H, that NH2, plus 2H2O. Then it says, explain why an aqueous solution is obtained in this reduction, even though phenylamine is insoluble in water. Okay, Well, because the C6H5NH2 is present as an ionic salt. That's really good. Why an aqueous solution is obtained even though it is insoluble in water? Yeah, it's because it's present as an ionic salt. Or you could say, yeah, present as an ion. Question 5. Aqueous solutions of ammonia, ethylamine, and phenylamine are prepared. Each solution has the same concentration, which is the correct order for the pH values of these solutions. So, remember with pH, what is pH? Acids and bases, it's minus log 10 concentration of H plus, right? So, in order for pH to increase, concentration H plus ions must decrease. So, okay, so ammonia, ethylamine, phenylamine. Well, ammonia is no. Ammonia is not going to have the highest pH values, and this is H plus. But for these, we're going to look at which ones are the stronger bases, because the stronger the base, they're going to accept more H plus ions, and therefore the pH will decrease. So I'm looking for the weaker bases for the final one. Yeah. So I already know from my knowledge of amines that ammonia is not going to be the one with the greatest pH value, because it's not going to be that. Now I'm left with C and D. Well, if I look at C, ethylamine, ammonia, phenylamine. Ethylamine, so I've got my aim is CH3, CH3, CH2, and then my NH2, my amine. Phenylamine is just something like that, really. And because of the benzene ring is delocalized, it's going to cause these the amine ring to become delocalized as well. So what will actually happen is it won't be a stronger base, it'll be a weaker base. So phenylamine, so let me just, phenylamine is the weakest base, Now what does that mean? Well, it's not going to accept a lot, it's not going to accept a lot of H pluses, and therefore what happens to pH? Therefore pH would increase, it would go up. So phenylamine is going to be the one with the highest pH value, since it's the weakest base. So therefore the answer will be C. If I look at D, ethylamine, yes. Phenylamine greater than ammonia pH value, no, because phenylamin's got that extremely strong delocalized ring, the benzene ring of delocalized electrons. It's not going to accept rarely any protons, and therefore it's going to have a really high pH value compared to ammonia. Question 6. This question is about three amines, E, F, and G. Explain E, F, and G are weak bases. Okay. Explain the difference in base strength of the three amines and give the order of the increasing base strength. Explain the difference and give the order of increase in base strength. Now, the thing about this question is all of these E, F, and G have the benzene ring. So I can't really, use that as a unique point to talk about. So I'm going to have to think a bit deeper here. Well, if I look at E, the nitrogen is next to the ring. Okay, that's I understand what I'm gonna have to do now. First things first, strength depends, strength of base, okay, base strength depends on the availability of the lone pair on nitrogen atom. As amine E, nitrogen is next to the ring, lone pair will be delocalized into the ring. Lone pair less available to donate / accept H plus ion. H plus. F or G, well, if I look at both of them, oh no, F or G next to alkyl groups, therefore positive inductive effect, electrons are pushed onto nitrogen, lone pair is more available to donate / accept H plus, and therefore order of increasing base strength should be E, obviously the weakest. Then if I look at G and F, well, I look at G, the nitrogen is still directly bonded to the benzene ring, so it will still be delocalized. Lone pair of electron will be delocalized into the ring, therefore it's going to be less available compared to F. So it's going to be E, G is obviously going to be greater than F, and F is going to be the strongest one with the strongest base strength. Part B, amine F can be prepared in 3-step synthesis starting from methyl benzene. Suggest the structures of 2 intermediate compounds. For each step, give regions, conditions. Only equations and mechanisms are not required. So the intermediate compounds. Methyl benzene. So step 1 product is going to be C6H5CH2Br. Step 2 product. Step 2 product. C6H5CH2Cn. C6H5CH2Cn. The regions and conditions of a step 1, I need chlorine and UV light, but in this case, because I've got the bromine, I need bromine and UV light. Step 2, KCN, alcoholic and aqueous. And then step 3, step 3, in order to get the amine, I'm going to need hydrogen with nickel. Hydrogen gas with nickel. Remember, this is catalytic hydrogenation. Question 7, which compound is the strongest base? Now, strongest base, what does base mean? Proton acceptor. So, if it's a proton acceptor, what's going to happen to pH? Well, pH, actually, this is not really that relevant for this one, but let's just go through it. pH minus 10 H plus. So, if it's going to accept a lot of protons, H pluses, the pH will decrease or decreases. So ammonia NH3, ammonium chloride NH4 plus Cl minus, methyl amine, so it's going to be methyl group, CH3, which is amine. Methylamine formula. Methylamine formula. Methylamine formula. Methylamine formula. Never mind. Phenylamine, well, it's obviously going to have the phenyl group attached to amine. And remember, the benzene ring delocalized is going to cause the nitrogen, the lone pair with actual nitrogen become delocalized onto the ring. Therefore, that is not going to be the strongest base. Ammonia also is not going to be, so I'm left with B and C. But ammonium chloride doesn't really have an alkyl group. It's got the H4 plus and Cl minus, whereas C, methylamine, does. Therefore, the answer will be C, methylamine. Question 8. Which type of reaction is used to convert CH3N into the cationic surfactant CH3N, CH250, CH3Cl? Bronsted-Lowry acid-base reaction? Definitely not. That's one you can just cross off immediately. And then the rest of these three options are very convincing. Nucleophilic addition, elimination, nucleophilic substitution. But it's the one you're not going to expect the most. The answer is going to be nucleophilic substitution, because all we're doing is CH3, 3N. All we're doing is, we're just substituting that in. Therefore, the answer would be 8, D, nucleophilic substitution. And that is the end of this question paper.